We have a few digital amateur television DATV enthusiasts here in Viewland also who transmit their own high definition visuals through the QO100 geostationary amateur radio satellite. HAMTV is DATV on board the International Space Station. Of course, it is quite different from the SSTV or slow scan television images which many of us in this region have received using Robo36 app in our mobile phone kept over the radio when ARIS passes over your region. HAMTV transmits digital video and audio in MPEG-2 format using the DVB-S protocol in the 13 cm band. So first we will have to make an antenna for the 13 cm band with rotator for tracking the satellite. Original HAMTV equipment was used for school contacts between 2016 and 2018, and I also seen a nice recorded version recently in which astronaut was talking to school children demonstrating weightlessness in space. HAMTV was sent back to Earth for repair when it failed in 2019 and has been repaired and sent back to the International Space Station in March 2024. Though the RF output of HAMTV transmitter is 10 watt, when it is fed through a series of cables and band pass filter, final power at the antenna is estimated to be about 2 watt with right hand circular polarization RHCP. We will need quite sensitive equipment to receive it. I saw a nice short video clip by G7JTT on X which showed a heavy duty camera pan and tilt unit getting ready for HAMTV reception. It has 360 into 90 degree movement. He has mounted a cute 13 cm antenna on it. He is planning to make Arduino based computer tracker as well. So people have already started preparing for HAMTV, which is expected to be commissioned by the end of this month. But we cannot be sure about the timeline, which has been postponed several times, I believe. When I went through the wiki on HAMTV of the British Amateur Television Club BATC, I read that most transmissions will be on 2395 MHz. HAMTV uses a simple patch antenna on the earth-facing side of the International Space Station. Challenges are there because many other items project below the antenna which may cause reflections. Potential instruments in this group are solar panels, thermal radiator panels, robotic arms of the space station, and spacecrafts carrying cargo and astronauts to the space station. Reflections from these could cause disturbance to the signal which we receive from HAMTV. An important challenge in HAMTV reception is that the transmit frequency 2395 MHz is just 5 MHz below the common 2.4 GHz Wi-Fi channel. It is needless to say that good filtering will be needed to prevent powerful local Wi-Fi signals from getting into the wideband tuner needed for HAMTV. It has also been mentioned that in some countries, 2395 MHz may be allocated to other services, which could also cause interference in HAMTV reception. A global network of large ground stations for HAMTV receptions have been formed so that a server can combine these signals and provide a longer period of good signals to the schools providing contacts with International Space Station. But due to the objects on the space station likely to block signals to some ground stations in particular orientations, there is a need for more smaller ground stations. That is why hams are trying to make their own smaller setups. Once the smaller setup is active, there is provision to combine their signals also into the dedicated server output so that still longer duration of stable HAMTV signals can be provided to the schools having the contacts.